Okay, so in this example, we're told that jet B is traveling due north with a given speed, and that passengers on jet B observe A to be flying sideways and moving due east. And given this information, we're asked to find the speed of A, and also the speed of A is observed by passengers on jet B. So the way I'm going to do this is I'm going to say, well, first of all, we can do a little bit of work here with velocity vectors, and I think I have probably enough room here to sketch it in. Basically, what we can say here is that the velocity of A with respect to B is going to equal the velocity of A minus the velocity of B. Now let's take a look at what we're given in this problem. We know in this case the velocity of A with respect to B is going to be some number in the I direction. And in this problem, in fact, we're not actually told what that is. It's something we're asked to determine. In addition, I know that the velocity of A is some speed VA, and I know it's vector projection here, so in this case, if I use conventional ij coordinates to be lined up with east and north respectively, I'm going to have this is going to be VA times the cosine of the angle theta in the I, plus the sine of the angle theta in the j. And then I'm going to subtract off of that VB, which I know is a given number that I know, in this case purely in the j direction. Now we want to keep in mind at this juncture that a single vector equation in a two-dimensional problem is actually two scalar equations, and so I can break up now the I and j components. If I look at the I component, I have that v of A with respect to B, that is the speed of A as observed by a passenger on jet B, is going to equal the speed of A times the cosine of the angle theta. And if I look at the j component of this equation, I'm going to have that 0 is equal to the speed of A times the sine of the angle theta minus VB. Now let's go ahead and call this equation 1 and equation 2. Now if I look at equation 2 here, I quickly realize that I know the angle theta as well as the speed VB. And so if I take 2, I can actually rearrange this to get the speed of plane A. Namely, I know that the speed of plane A is going to be equal to the speed of plane B divided by the sine of the angle theta. I can then take that information and substitute it into equation 1 to get the speed of A as seen by a passenger on plane B, the second quantity we're asked to find. In this case, it's going to be VA times the cosine of the angle theta, which of course is going to end up being VB times the cosine of the angle theta divided by the sine of the angle theta. Okay, I think that just about wraps up this problem. I'll leave it up to you to plug in VB as well as the angle theta and wrap this thing up. Best of luck.